Okay, welcome back. So today we're going to be looking at a different way we can visualize our multi-step or independent or chance experiments. So let's get started. It's called a tree diagram. Now, if you want to use the table or a tree diagram, totally fine. You don't have to use one or the other. It's whichever one works the best for you. Alright, so let's get started. So a letter is chosen from the word sun, and then a letter is chosen from the word map. Draw a tree diagram to show all the possible outcomes. Alright, these are pretty simple. So the idea is that we have our first choice, and then our second choice, and then we have our outcome. Now, depending on the question, you might write something else instead of choice. Right. Usually it's better to start with your second choice first. And in this case, we have M-A-P, M-A-P, and M-A-P. And the reason why we have this 3 times is because our first option is going to correspond with drawing one of the letters from sun, and then our second option could be any one of the letters of map. After we're done, we're just going to draw a bunch of lines from our first choice to our second choice. Right, and then we can usually have a starting point for our tree. Now, it's important to note that you can do this in a vertical orientation rather than horizontal, and sometimes that's better because these can use up quite a lot of space. Also, a lot of the time, I used to draw a circle around each one of my independent events. Now, once we've done with that, we can run along each one of these to see what the outcomes are. So we can draw an S, and then we can draw an M. We can draw an S and an A. An S and a P. Another outcome, if we draw a U, it would be UM, UA, UP, and then NM, NA, and NP. So these are all the possible outcomes, right? And we can see that each group is 3, means that there are 9 total outcomes. So this can be a good way of also organizing events when there are different probabilities of situations happening. Obviously in this one, everything has the same likelihood of occurring. But that won't always be true, and tree diagrams can be used to basically improve our understanding of complex situations. Alright, let's quickly look at another one. So we have a spinner with the numbers 1, 2, and 3, and it's spun twice. So we're going to draw a tree diagram to represent the sample space, and then write down all the possible outcomes. So again, instead of choice 1, we'll just do spin 1, and then spin 2, and then outcome. Alright, so again, we're going to start out by putting all of our options for spin 2, and then all of our options for spin 1. And then just draw out your lines. Right, so once we've done that, we can do our outcomes. So we can get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 2 and a 1, a 2 and a 2, and a 2 and a 3, and a 3, 1, 3, 2, and 3, 3. Those are all our possible outcomes, and they've all been written out. So essentially this is B and this is A. Alright, so writing out these takes up a lot of space, and the more different events we go through, the bigger this tree will get. And one of the challenges in drawing this is leaving enough space so that you can draw it out, but also so that you can read what each outcome is. For now, we're just going to look at drawing them and determining what the outcomes are, and then afterwards we'll look at doing probabilities on these.